Concentration versus strength. What does it mean? What's the difference? How do I see the difference and understand the difference? That's what we're going to look at today on Chemistry Crackers. Right, welcome again to Chemcrackers. So today we are looking at the difference between acid concentration and acid strength. Let's start by just looking at the nature of an acid. An acid is a substance which dissolves in water to produce hydrogen ions, H plus ions. It is actually the H plus ions that are the active ingredients in an acid. So if an acid burns you, it's the H plus ions that do the damage. So let's look at the definitions of concentration and strength. What do we mean when we say an acid is concentrated, and what do we mean when we say an acid is strong? And what's the difference? Now, acids are substances that dissolve in water to produce H plus ions. Now, that is actually a simplified equation to show what happens. In fact, the H plus ions combine with water molecules to form hydronium ions, which are actually H3O plus. But we don't need to use that more complicated form of the H plus ion. It is actually the H plus ion that is the active ingredient in the acid. So, how strong an acid is depends on how much H plus ion it releases in water relative to how many molecules you added in the water in the first place. Now, so this is my acid here, HX. And let's talk about the concentration of the acid. The concentration of anything is the amount of substance over the volume of the solution. All right? So it's amount of substance over the volume of the solution. So when we say an acid has 10 mole per decimeter cube concentration, this means, right? This means that we have 10 moles of acid, let's say HX, in 1 decimeter cube or a liter of solution. That's what we mean by concentration. The amount of substance in a given volume of solution. Now, the strength of an acid is really a measure of how dissociated or ionized the acid is in solution. So, we know that the acid dissociates to give us H plus and an anion in solution. But this dissociation is not the same for different acids. So there are some acids that are fully dissociated. So if I put 1,000 molecules of HX in water, for example, then the whole 1,000 of them, are close to 1,000, 999 or 998, dissociate, break down to give you H plus and X minus in solution. Those acids are called strong acids. And then you have weak acids. They only dissociate slightly in solution. So a weak acid might only dissociate by about 1% or 2% or even less. Now, that means that the amount of hydrogen ions that the acid produces in solution relative to the amount of acid that you have depends on the degree of dissociation. That is what we mean by strength. Is the acid fully dissociated, partly dissociated, or only slightly dissociated? It varies with different acids. If you want to understand the strength of the acid, you have to understand the degree to which it is dissociated, its strength. Here is a dilemma. I have 2 beakers with acid. one with 12 molar ethanoic acid, a weak acid, and one with 5 molar HCl, a strong acid. Suppose somebody held a gun to my head, or to your head, and said, you have to push your fingers in one of them. Which one would you put your fingers in? We're going to find out the answer to that. And we're going to try it practically and show you the results at the end of this video on Chemcrackers. Let's look at this activity. In this activity, we're going to differentiate between strong concentrated acid, strong dilute acid, weak concentrated acid, and weak dilute acid. Let's start by sorting out the strength first. So, remember that what we said, a strong acid is one that is fully dissociated in water. So the acid that we're going to be looking at is a generic acid, HX. And when it dissociates in water, it gives H plus ions and X minus ions. Now, let's start by looking at the strong acids. Now, the strong acids are fully dissociated in water. That means that we are going to have a lot of H plus and X minus ions. And relatively few or none of the molecular HX acid. And we will do the same for the other strong acid. Lots of ions, few molecules. That's the strong acids. On the other hand, the weak acids will have lots of molecular HX. But relatively few ions in there. So we've sorted out the strength. Strong acids have lots of ions, very few, if any at all, molecules. Weak acids have lots of molecules, very few ions. Now, that's the strength sorted out. Let's sort out now the concentration. Now, we say something is concentrated when it has a lot of solute in a relatively small volume of solvent. We say that that is concentrated. But if we have a lot of solvent in the solution and only a small amount of solute, we call it a dilute solution. Okay, now let's sort out the concentrated solutions. So the concentrated solution means therefore that you will have a lot of the acid. Now all of these represent the acid, the molecular form and the ionic form. And then what you will have is relatively few water molecules. That is your concentrated acid. And so we have dealt with both strength and concentration. On the other hand, your dilute strong acids will have lots of water molecules. The water molecules will dominate. It's still strong. The acid still dissociates mostly to give you ions, but it's in a dilute solution, which means that you have a lot of water molecules involved. Let's come down now to the weak concentrated acid. We said that this acid is weak, lots of molecules, lots of molecular acid molecules, very few ions. If it's concentrated, then it only has a few water molecules in there. Okay? On the other hand, if it's dilute, still a weak acid, lots of molecules, few ions, this is dilute, then you have a lot of water molecules relative to acid molecules or acid ions. So, there we have it. The difference between acid strength and acid concentration. Concentration has to do with the amount of acid relative to the solvent that it's in, that's water. If you have lots of acid to relatively small amount of water, then that's a concentrated solution, as in here and here. If you have lots of water molecules and few acid molecules or ions, then those are dilute solutions. Strong acids have lots of ions, lots of acid ions, lots of H plus and X minus ions, and relatively few HX molecules, as in here and there. And weak acids have lots of molecules and very few ions, as in there and there. And that's the difference. It's decision time. Do I push my finger in the 12 molar ethanoic acid, the weak acid, or in the 5 molar HCl, the strong acid? I ain't gonna lie, I'm sweating a bit. But I think I made up my mind, and I'm going to choose one. Don't worry, folks. Just some red dye and baking soda and a little vinegar does wonders, but no damage, no permanent damage. Don't try that at home, okay? But do like the video, share the video, subscribe, and join us next time on Chemcrackers.